Welcome to the last part of polygons. We have one more set of problems to do and you will have finished your second module. So I am in the polygons chapter, and rather than scroll through all of that, I'm just going to jump ahead to the next problem. And this is perimeter and area of a parallelogram, and then perimeter and area of a trapezoid. So on this first one, we're looking at a parallelogram. And let me just remind you of the anatomy of a parallelogram. It's one of my favorite shapes, really. And I am going to put in those vertex points just to mark the ends of these boundaries. This base and this base are equal. So if that bottom one is 13, this top one will be 13. And then we have the other sides, the width of the polygon. So we have the 6 units there and the 6 units over here. If it helps you, go ahead and write in those numbers. I always like to see all of my dimensions before I started a problem. So those are the outer dimensions. And then the inner dimension of height is what connects the top to the bottom. And you can measure it there, or you can measure it there, either way. So both of those show the height of this problem. Okay, the perimeter, there is no formula. We're just going to have to use our old standby knowledge of perimeter. And that's simply to count your sides. This polygon has 4 sides. We have side 1, side 2, side 3, and side 4. If this were a decagon, we would have 10 of those. Pentagon, 5 of them. So you just count your sides, and that is your perimeter formula. Remember, for perimeter, we cannot go inside the shape, so we're not looking at the green dimension. I'm going to start at the top with the 13, and then coming around, another 13, and another 6. And to get the perimeter, you simply add those up. And you should come up with 38 units for the perimeter. The area formula for perimeter is pretty basic. It is just area equals BH, or area equals base times height. So we put in A, pocket for B, and a pocket for H. The base is 13, the height is 5. That's all we're asked for. The 6 does not go in this problem. 13 times 5 is 65 square units. Okay, the trapezoid here at the bottom, and I left this one for us to count. This is drawn to scale so we can figure out our dimensions ourselves. And let me just go ahead. My nose is itching so badly. I'm sorry if I sound funny. We need to count this top, and that looks like 8 units here. And then we need to count the bottom, and that's going to be 16 units. And then this is a right angle. 1, 2, 3, 4. The height is 6 units. And I should use the Pythagorean theorem to find these sloped lines, but I am just going to estimate here that those are about 7 units. This is not to scale exactly, but for the purpose of our example, let's just estimate. It would be a decimal number if we got the exact answer. So here I have this dimension, and down here I have this dimension. We have our height, which is in here, and then we have these slanted lines, and those two are identical, so we'll color those the same. And this one would be identical also if we needed it. So to get perimeter, again, there is no formula. You just have to use your basic perimeter formula for a 4-sided figure. So side 1 plus side 2 plus side 3 plus side 4. And remember, with perimeter, you are not allowed to go inside the shape. You can only stay on those lines. So starting up at the top, I'm going to use the 8, and then coming around the sides, we do not go inside, so we do not use the 6. We just use those outer numbers. So perimeter is 38 units. For this trapezoid. The area formula for the trapezoid is pretty ugly. As these shapes get more and more complicated, so do the formulas. So this one says area equals 1/2 times the height times the sum of the bases. So we're going to have to add our bases together to get part of this formula. So let's put in the spaces that we need to fill up. We need one for h, and we need base 1 and base 2. So ask yourself, what is h? Height is 6. That is this pink dimension. Base 1 doesn't matter. I'm going to use the 8. To me, that top one is always my 1, but you could do that either way. And then the other base is the 16. That's the bottom one in my case. So those are the pieces of this formula. It does not ask for the side or the width. So the 7s don't get to play here. They are just for perimeter. Okay, the next step would be to go ahead and add your bases. So 24 when you add 8 and 16. And then you're left with the height still and the 1/2. And once you get to this point, really the step above, you could put in the calculator with parentheses. And I showed you in the tutorial how to do that. But here you're going to type 1/2 times 6 times 24. I got 72, but that doesn't feel right. Let me do one. Yep. So 72 square units. For this particular area. And that is not an easy formula. We're getting into the harder formulas. Remember, we started out with a square, which was pretty basic. So in the next video, we will be moving into the circles chapter. But if you flip back through what you have learned in this module, it's pretty amazing. You've got a lot of knowledge in these pages. And now that we are to the end of polygons, I would encourage you to take the module exam and make sure that you can do these problems on your own. If you're having problems, remember to contact me back in the contact information. I'll be happy to help you. But once you feel comfortable with polygons, we'll move on to circles, and you'll learn some new terms and some new formulas. So I'll see you in the next video, and I hope you have a great day.